Infrastructure can be described as the underlying structure of a country and its economy, the fixed installations that it needs in order to function. These include roads, bridges, dams, the water and sewer systems, railways and subways, airports and harbours. These are generally government-built and publicly owned. For UAM, this can be understood as the basic equipment and structures that are needed to execute the UAM operation with the UAS. Infrastructure consists tangible elements, vertiports, passenger terminals, goods terminals, maintenance facilities, charging stations, as well as non-tangible elements, airspace design, approach-departure routes, dispatch services, satellite tracking, and weather reporting. A UAM operation needs infrastructure for taking off flight, landing, servicing and preparation for the next flight. Operations to deliver goods also need infrastructure to deliver the goods. Operations to transport people also need infrastructure to facilitate the movements of these people and their luggage. The servicing of the UAS needs facilities to perform post-flight and pre-flight inspections, maintenance, and for refueling of the aircraft or for reloading the batteries of the aircraft's propulsion. Infrastructure for the flight depends on the applicable rules of the air. This includes infrastructure that may be needed for air traffic services, also remote, and for U-space services. In general, UAM infrastructure components are as following: ground station specifications, light specifications, UAM, UTM, U-space, ATM, passenger and emergency response facilities specifications, heli vertipads, vertiports specifications. The urban air mobility and its future integration into urban transportation. UAM is a novel concept based on the use of vertical takeoff and landing vehicles for aerial transportation of people in urban and peri-urban environment, but its integration into cities and within the existing transportations mode needs a completely new approach. Although it will take some time for the technology to be fully in service, it is important to prepare supporting the cities with recommendations to allow the UAM integration everyday life equal to surface transport. UAM needs to be integrated into the urban context. To do that, a series of actions will be necessary to adapt the cities and allow them to accommodate this new mode of urban air transport. The operational limits, barriers, to the development of the UAM can be divided into three macro categories. 1. Ground infrastructural limitations. Ground infrastructures necessary for passengers embarking, disembarking, and flight and landing operations. 2. Technological limitations. Propulsion, capacities, covered distance, and so on. 3. Social limitations. The basic characteristics of the UAM vehicles. The green circles in the figure are the vehicle's requirements, while the external boundary condition is expressed by dark green circles, and the light green circles report further design drivers. Within the technological limits, in addition to the enabling vehicles, there are all aspects related to ICT and U-space service. The ICT domain-related applications that can be used to support UAM and multimodal transport include Internet of Things, communication technologies, big data processing, smart cities concept. Another important aspect to ensure the integration of the UAM in the urban context of the city and with all existing transport mode are certainly the U-space services, which in their final phase, the whole environment will need to integrate safely with manned aviation and air traffic control. As this important and growing domain evolves, new operational concepts, regulations and standards will be needed, underpinned by existing and new technologies. Drones could significantly impact on the natural environment. There are many important aspects to consider when implementing unmanned vehicles in cities. Environmental issues constitute one of the more important topics, so many possible events and undesirable effects should also be taken into account so as not to disturb our natural environment in which we live. Wildlife protection is one of the main concerns of the European citizens when considering the potential large number of aircraft flying in the lower levels of the atmosphere. Many aspects are important to consider when implementing unmanned vehicles in cities. It means noise, impact on wildlife, birds, disruption of habitat, impact on flora, noise pollution, greenhouse gas emission, visual pollution and energy consumption. Environmental issues constitute one of the more important topics, so many possible events and undesirable effects should also be taken into account so as not to disturb our natural environment in which we live. Urban air mobility, impact on natural environment, drone impact on wildlife, disruption of habitat, impact on flora. As regard impact on birds, we have provoking attacks, scattering, birds' reproduction and survival, collision during provoking attacks, mid-air collisions, interrupting feeding. The EU Aviation Safety Agency, EASA, is developing rules for UAM facilities, i.e. vertiports, in 2 stages. In the first stage, EASA has introduced in March 2022 the PTS-VPT-DSN as non-regulatory material for the design of VFR vertiports or parts thereof, applicable for the operation of manned VTOL-capable aircraft certified in the enhanced category. In the second stage, the rules will cover a full set of vertiport rules, including the authority, vertiport operator, and vertiport operation requirements, will be introduced along with the certification specifications, CSs, and guidance material, GM, for vertiport design and certification. Heli-Vertipad's Vertiport Specifications Section 9.6 Refueling Safety Requirements, including fire extinguishing equipment. UAM, UTM, USpace, ATM, the Global UTM Association, released a document describing an overall height-level unmanned aircraft systems traffic management, UTM, architecture for all types of UAS operations, VLOS, EVLOS, BVLOS, piloted, RPAS, and autonomous. Ground Station Specifications FAA AC 150 5230 4C. It contains specifications and guidance for the storage, handling, and dispensing of aviation fuel on airports. Lighting Specifications CAO Doc 9157 Guide to the recommended electrical engineering practices for design and installation of new systems and the modification of existing systems of aerodrome fixed lighting. Passenger and Emergency Response Facilities Specifications EU Regulation 139/2014 on aerodromes shows the security and safety requirements for aerodromes and the demonstration of procedures to guarantee the passenger safety requirements to screen passengers. The EU Aviation Safety Agency, EASA, is developing rules for UAM facilities, i.e. vertiports, in 2 stages. In the first stage, EASA has introduced in March 2022 the PTS-VPT-DSN as non-regulatory material for the design of VFR vertiports or parts thereof, applicable for the operation of manned VTOL-capable aircraft certified in the enhanced category. In the second stage, the rules will cover a full set of vertiport rules, including the authority, vertiport operator, and vertiport operation requirements, will be introduced, along with the certification specifications, CSs, and guidance material, GM, for vertiport design and certification. Some consideration could be done to ensure an efficient integration of the UAM into existing transport systems, by the way considering data exchange standard between the operators. It is essential that 1. There is a single standard of data exchange between different transport systems and the different operators. 2. All information should be sharing between operators and transportation service providers. 3. Availability to have alternative in the round trip to overcome any disruptive scenario that may give late in the journey, and this is possible only sharing information between all existing transport modality. ICAO has specified 4 main requirements for UAS ATM integration that shall not imply a significant impact on current users or the airspace, comply with the existing and future regulations and procedures laid out for manned aviation, not compromise existing aviation safety levels, nor increase risk more than an equivalent increase in manned aviation would, be conducted in the same way as those of manned aircraft, and shall be seen as equivalent by ATC and other airspace users. An overall high-level unmanned aircraft systems traffic management (UTM) architecture for all types of UAS operations, VLOS, EVLOS and BVLOS, piloted RPAS and autonomous is described by the Global UTM Association GUTMA, a common framework with core principles for global harmonization published by ICO provides a framework, principles and list of services for a typical UTM system that many member states. The future integration of all aerial vehicles in the European ATM Master Plan is divided into 4 following phases: A, B, C, D, including digitalization, supporting infrastructure and innovation. Noise issues are primarily regulated by the following directives: Directive 2015-996. This directive requires member states to determine exposure to environmental noise through noise mapping by common assessment methods and adopt action plans based upon noise mapping results with a view to preventing and reducing environmental noise where necessary. ETSI EN 300-753 V1.3.1 specifies acoustic noise emission limits for equipment used in telecommunication locations be considered when planning vertiports. Other important documents regulating this issue are FAA 14 CFR Part 150, FAA 14 CFR Part 161, FAA AC 150, 5021, and ISO 11204 2010. Standards for bird populations are defined by Birds Directive. It promotes research to underpin the protection, management, and use of all species of birds covered by the directive. It shall be used in the vertiport planning. In the context of flora and fauna under the Directive 9243 EEC, the EU countries have an obligation to set appropriate protection targets and to put in place appropriate measures, ensure the population of habitats in these areas, avoid deterioration of habitats and significant species disturbance. Standards for visual pollution are defined by Regulation 2019-945. It establishes the general requirements for the lights with which the UAS should be equipped. Energy consumption issues are primarily regulated by the following directives: ICAO DOC 9157 Part 5. It provides guidance on the design and installation of electrical systems for aerodrome lighting. ED Decision 2022-005-R. The objective of this decision is to facilitate the implementation of the new requirements on fuel energy planning and management introduced into Regulation EU number 965/2012, the Air OPS Regulation, by Commission implementing Regulation EU 2021-1296. It includes hydrogen, which can be used as a fuel for fuel cell application and other sources of energy for aircraft propulsion, such as stored electrical energy. This decision replaces the term fuel used in Annexes 2 to 8 with the term fuel/energy, where the term energy refers only to the electrical energy used for aircraft propulsion purposes. Recommendations for UC 2025-1 Direct Last Mile Delivery in the context of operations address delivery of goods that are lightweight, small, compact, and do not need special conditions like temperature maintenance. Delivery by an intermediate landing or lowering the parcel with a tether while hovering. Network of parcel share points to pick up or to drop the payload suitably accessible for service recipient. For UC 2025-2 point-to-point public services, operations are defined as medical transport. Blood samples, blood for donation, or human plasma are life-saving products which, in case of an emergency, need to be immediately delivered to hospitals. Delivery by an intermediate landing, network of parcel share points to pick up or to drop the payload suitably accessible for service recipient. Recommendations for UC 2030-3 Advanced Last Mile Delivery. In the context of operations address, operation, heavier cargo aerial services for delivery of more than one parcel at different locations, almost any cargo except dangerous goods like e.g. chemicals, deliveries over a wide area including suburbs to recipients directly or via parcel share points, network of registered landing pads to be available through the city, private landing sites areas, and pads. For UC 2034, Point to Everywhere Public Services, operations are defined as operation, medical transport such as blood for donation, blood samples, human plasma, laboratory samples, including medical goods that classify as dangerous goods, daily routine exchange between blood banks, not restricted to designated landing sites, but landing wherever needed, e.g. at an accident site under supervision of a human operator and/or emergency services rescuer on site. Recommendations for UC 2030-3 Advanced Last Mile Delivery in the context of operations address. Transport of a hospital patient who is in relatively good health and is transported to a facility for treatment, testing or consultation, not needing on-board medical assistance. Non-commercial transport. Vertiports near hospital or other medical institutions that may be connected by predefined routes, flight corridors. For UC 2035-6, automatic personal aerial transportation operations are defined as operation, non-commercial unmanned passenger transport from to urban areas, network of predefined routes, flight corridors connecting the various landing sites in the city. For the effective integration of UAM components in cities, it is important that industry, international researchers and scientists, academics, as well as business sector units and organizations involved in the development of guidelines, standards and regulations engage in the preparation and implementation of regulations covering a wide range of issues. It is an important aspect that the integration of UAM with cities' networks and operational systems is not even included in plan of municipal authorities due to the lack of relevant regulations, availability of infrastructure dedicated to the emergent mean of transport, or even by the lack of knowledge about UAM deployment and societal acceptance. Therefore, there is a need to recognize the role of the cities and regions authorities as one of the most competent in city governance and involve them to the governance of the urban airspace. Based on thorough research and literature review, this document examined the regulation state with respect to the UAM components and has revealed that there is a need for a comprehensive approach, which will be essential to prepare the future common regulatory framework and UAM implementation, regardless of geographical area. Should consider that to provide UAM transportation for consumer use, there should be considered a variety of complex regulatory issues and certification challenges with social consent and acceptance.